Alright class, in this set of videos we are going to be working with systems of equations. I'm going to be giving you three different methods to solve what we're going to call systems. One's a graphing method, there's a substitution method, and an elimination method. And I'm going to go ahead and tell you this concept kind of pulls together a ton of what we have been doing in class over the school year. And so that's one reason I have been stressing the importance of really learning slope-intercept form, really becoming comfortable with graphing. We've talked a lot about substitution. We have eliminated things in the past, working with equations with variables on both sides. All of those skills are coming together to be able to solve these systems. So we want to start with the graphing method, but I want you to think about this definition right here. What's a system of equations? It's where two or more equations with the same set of variables. Two or more equations with the same set of variables. And so here we have two equations. We have y equals 5x and y equals 2x plus 30. Now when we talk about system of equations, the solution, and I've given you the solution here, it's 10 in the x and 50 in the y. So this is a coordinate point. In fact, why don't we go ahead and map that? We're at 10 in the x and 50 in the y. And so we can actually solve, we can map this point right here on the xy axis, right? This Cartesian coordinate grid, 10 in the x and 50 in the y. Well, what if I didn't know this? What if I did not know what the solution is, and I give you two equations and ask you, find the solution? Well, there's several different ways to do this, as I've already mentioned. Let me show you this. What if I take the 10 and the 50? Let's bring the 50 over here first. Watch this. What if I substitute the 50 in for y, and the 10 in for x? Now this is something that I've been doing a lot in class. We're just simply substituting the 10 in for the x and the 50 in for the y. Now watch what happens. 5 times 10 is 50. Well, you'll remember when we were checking our work in the past, in the first semester, we knew that if we got the same number on both sides, okay, it's correct, right? Unless we've made offsetting errors, that is correct. And I can do the same thing here. What if I plug in 50 for the y and go ahead and plug in 10 for the x? Remember to use your parentheses. Here I have 50 equals 2 times 10 is 20. 20 plus 30 is 50. And so let's look at it a different way. What if I graph y equals 5x? Now that's going to be direct variation. So I know the y-intercept is going to be at 0. My slope is going to be up 5 over 1. And so that's going to be 5, and 1's going to be right about in there, and boom. It's going to look something like that. It's a little shaky on the graph, but we can work with it. What about y equals 2x plus 30? Well, there's 10, 20, and then 30. In this case, I'm going to go up 2 and over 1. And it's hard because this graph is huge, but it would look just like that. And so what happens? They intersect at the same point. I'm going to cover that purple. They intersect at 10 and 50. That's your solution. So the solution right here, it's where these two given equations, y equals 5x and y equals 2x plus 30, it is where they cross or where they intersect. That's the solution. All right, given that, let's work through a couple of more examples here. All right, so this first example, y equals negative 2x minus 3 and y equals 2x plus 5. Now, I've written them this way because this is how we're going to see them written in our homework, in our classroom examples, YouTube examples. They're going to be written vertically. Now, when we get to the elimination method, that's very important. That's really the chief reason we do it this way. One, it is convenient, it's nice and orderly, but it also sets us up to solve the elimination method. But we'll get to that in a future video. For now, why don't we actually start by graphing these? Hopefully you see that both of these are written in the form of y equals mx plus b. And I hope you were able to recognize that immediately. We've done a lot of work with that. Let's start graphing our first equation. We see our y-intercept is negative 3. That's going to be right there. Our slope is negative 2 over 1. So that means I'm going to go down 2 and over 1, down 2 and over 1. I could also go up 2 and over 1. And so this line is going to look something like that. All right, let's graph our next one. Plus 5. 1, 2, 3, 4, 5. So the y-intercept is 5. The slope is 2 over 1. So I'm going to go up 2 and over 1. Now, as we talked about in class, we can also go down 2 and to the left 1. If both are positive, or excuse me, if both directions are negative, and negative divided by negative is, well, a positive. So I'm able to map it out this way. All right, now as I look at this, I can tell that I got a little free with my red graph here. Let's go back to this point, and our slope was negative 2 over 1. Well, that means I can also go up 2 and over 1, up 2 and over 1. So this graph should really come through here like that. Now, there they crossed, didn't they? And did you see how I was marking my slope? Negative 2 and a positive 1. That is the intersecting point. What if we can prove this? What if we said, okay, let's just take our first equation, and let's do a little check here. And we're going to take y is equal to negative 2x minus 3. I'm going to sub in 1 for my y. Negative 2 is the slope. This next negative 2, that's this x value, minus 3. So 1 is equal to negative 2 times negative 2. That's a 4 minus 3. And that's a 1 equals 1. And that checks. That is correct. So the solution to this system of equations, this is a system, all this right here. The solution to this system of equations is negative 2 and 1. And remember, the solution is where they cross, where they intersect. Now I want you to pause the video, try this practice problem, and then restart the video to see if you answered it correctly. All right, well, hopefully you did what I asked you to do. Why don't we start by graphing both of these? Y is equal to 4x. Now remember, that's a plus 0, so this is direct variation. We're going to start at the 0, and we're going to go up 4 and over 1. And so let's mark that point. But let's do the same thing in the other direction. Down 4 and this way 1. And so this line is going to come, got a little off there. We'll correct that. And now let's graph y equals x plus 3. So 1, 2, 3, positive 3, right there. That's my y-intercept. And my slope is 1 over 1. So I'm going to go up 1. Look at that. That's where they cross, right there. Boom. So this point right there. And that is going to be 1 in the x and 1, 2, 3, 4 in the y. Now we've got to check it. Graphing these, we can get off so quickly, so we have to check it. Why don't we use our first equation, y is equal to 4x. You can use the second, it doesn't matter. Plug in 4 for the y. There's 4 of my slope. And then for the x value, it's 1. And you can look at that. 4 does equal 4, so that is a check. This is the solution. It's where they cross, 1 in the x and 4 in the y. Let's look at some other examples. 2 more quick examples. And so let's look at x equals 3 and y equals negative 6. Now here we have no slope on these lines. So x equals 3. So that line is going to come straight through here. That's x equals 3. And then y is equal to negative 6. 1, 2, 3, 4, 5. Oop, almost didn't go too far. That's a negative 6. And so this line is going to come straight through here like this. So where do they cross? Right there. Right there. And that's going to be 3 in your x and negative 6 in your y. Now that one's very easy to check. If you were to go back up here, you just plug in 3 for x. Okay, well that checks out great. You plug in negative 6 for y, and that checks great. So these are super easy to graph, but there is your solution. Remember, it's where, can't spell solution here, that's an L. That is your solution. A solution to a system of equations is where they intersect. You're going to hear me say that a lot because it's imperative you get that to understand this concept, whether we're using the elimination, substitution, or the graphing method. I want you to pause the video and go ahead and try this practice problem. All right, so now that we are back, you have hopefully done that. We're going to go to x equals negative 1. So that's x equals negative 1. Y is equal to negative 4. And there we go. They intersect right there. They intersect at negative 1 and negative 4. And that's your solution. And again, you can plug either of these values in, and you see that negative 1 equals negative 1, and negative 4 equals negative 4. All right, guys, I hope this helps. We're going to keep going through this first lesson in another video.